Hi everyone. Today we're going to study compound proposition and precedence of logical operators. Let us define compound proposition. Compound proposition is a proposition which is a combination of two or more propositions and connected by one or more logic operations. Let's see this example 1. Here we have three propositions. Proposition P, it rains tonight. Proposition Q, I will stay at home. Proposition R, I will read a book. The instruction is translate the logical expression P implies the compound proposition Q and R into verbal expression. The answer is, if it rains tonight, then I will stay at home and read a book. Example 2. Translate the English sentence into a logical expression. You can access the internet from campus only if you are a computer science major or you are not a freshman. For our solution, let us assign the logical values. Proposition A, you can access internet from the campus. Proposition C, you are a computer science major. Proposition F, you are a freshman. The answer is the compound proposition C or not F. This implies A. This is the final answer. Let's see now the precedence of logical operators. Compound proposition can be constructed by using any number of the logical operations. The main important thing is to know the order of the operations in which logical operation in the compound proposition is to be applied first. Last time we studied the operations. These are the negation operation, which is not. This is the symbol for conjunction operation, and we read this as and. The next is the disjunction operation. We read this as or. Followed by the exclusive or operation, or simply said, we say XOR. Next is the implication, and this arrow is read as implies. The last one is the biconditional operation. We read this symbol as if and only if. With this list of operations, this is the same precedence or priority lists that we shall follow. Further, we shall use parentheses to specify the precedence of the operation. Example 1. What is the truth value of A and the compound proposition B or C when A and B are false and C is true? For our solution, let us write again this problem down here. Then let us substitute each of the propositions by its truth value. The A is false, the B is false, and the C is true. Now, because of the parentheses, we shall simplify this operation first, false or true. We know that the truth value for false or true is true. Now, the false and true is false. This is our final answer. Example 2. Determine the truth table of not P or Q. For our solution, let us first write the two columns for P and Q respectively. So we write all the possible combinations of truth values for P and Q. For the P, we have the first two rows to be true, the last two rows to be false. For the Q, we write the alternating true, false, true, false. Next, let us write the third column, that is for not P, based on the given problem. So we will negate the P. So the T here now becomes false, T becomes F, false becomes true, F becomes T. Now for the fourth column, not P or Q. Remember that for the OR operation, it becomes false only when both of the two propositions are false. So T and F is T, F and F is false, T and T is T, F and T is T. This is the final answer. Example 3. Determine the truth value of the compound proposition not P or Q, then and not R. For our solution, let us write three columns for P, Q, and R. Here we need 8 rows for each of the propositions. For the P, we write the first 4 rows to be true, the last 4 rows to be false. For the Q, we have the first 2 rows to be true, second 2 rows to be false, and we follow the same pattern on the last 4 rows. For the R, we write the alternating true, false, and so on. Another column is for not P. So we negate the P. For true here becomes false here. And that is the pattern here. Next, we write the column for not P or Q. In here, this becomes false only when both of the propositions are false. So we have this F and T is T, F and T is T, F and F is F, F and F is F, T and T is T, T and T is T, T and F is T, T and F is T. So we have completed our column here. Next is the not R. We shall negate the R column. So the T becomes F and the F becomes T and the pattern is followed. And the last column is our not P or Q and then and not R. So this column here and this column we will combine with the AND operation. Remember that for the AND, this becomes true only when both of the propositions are true. So T and F is F, T and T is T, F and F is F, F and T is F, T and F is F, T and T is T, T and F is F, T and T is T. This is our final answer. I hope you learned something from this video. See you again next time.